How often do you think about where the energy you use every day comes from? Have you ever pondered the journey your morning coffee takes from the kettle to your cup? It's not just about the water, the coffee beans, or even the electricity that powers your kettle. It's about the source of that electricity and the environmental footprint it leaves behind. Our world is in the grip of an energy crisis. Traditional energy sources are depleting at an alarming rate, and our global energy demands are skyrocketing. The environmental impact of these sources is also a pressing concern, contributing to climate change and impacting biodiversity. We're in dire need of innovative, sustainable energy solutions that not only meet our increasing demands, but also minimize our environmental impact. In the quest for these solutions, scientists are turning to the world around us, exploring unconventional energy sources that are often overlooked. The solution to our energy crisis might be closer than we think. It might be all around us, in fact. Have you ever heard about energy harvesting technologies? Well, you're about to. Imagine a world where your smartphone charges itself from the heat of your pocket, or a pacemaker powered by your own heartbeat. This isn't science fiction. It's the exciting world of energy harvesting technologies. At its core, energy harvesting is about capturing the tiny bits of ambient energy that surround us every day and converting it into usable electrical energy. It's like catching raindrops in a bucket, but instead of water, we're collecting energy. Let's break it down. Ambient energy is everywhere. It's in the heat that radiates from our bodies, the light that streams through our windows, and even in the vibrations from the bustling city or a humming refrigerator. Typically, this energy dissipates into the environment, unused. But what if we could capture it and use it to power our devices? That's where energy harvesting technologies come into play. They're designed to capture, convert, and store this ambient energy. You might think of them as a bridge, connecting the world of unused energy with the world of electronics. On one side, we have this vast, untapped resource of ambient energy. On the other side, we have our power-hungry devices. Energy harvesters act as the bridge between the two, turning previously wasted energy into something useful. The beauty of energy harvesting technologies is that they offer a sustainable, renewable source of power. They're like tiny, personal power plants that don't require fuel or produce harmful emissions. Instead, they simply tap into the energy that's already around us, making them a promising solution for a future where energy efficiency is paramount. But don't just think of these technologies as distant future concepts. They're here now, being used in a variety of real-world applications. From powering wearable devices to remote sensors, energy harvesting technologies are not just saving power, they're changing the way we think about energy. Energy harvesting technologies are not just concepts, they have real-world applications that are changing lives. Imagine if every step you took powered your phone. Sounds like science fiction, doesn't it? Well, it's not as far-fetched as it might seem. There's a fascinating field of energy harvesting technology that is focused on harnessing the power of ambient vibrations. These vibrations could come from any number of everyday sources: the rumble of traffic on a busy street, the roar of a passing train, or even the simple act of footsteps on a pavement. Let's take a look at one innovative case study. A team of engineers at the Georgia Institute of Technology developed a pioneering technology known as the triboelectric nanogenerator. This device captures and converts mechanical energy from ambient vibrations into electrical energy. The process is similar to the static electricity that builds up when you rub a balloon against your hair. So, how does it work? The triboelectric nanogenerator consists of two sheets of different materials. When these sheets are brought into contact and then separated, a process called triboelectric effect, an electric charge builds up. This charge is then captured and stored for future use. The potential applications of this technology are truly exciting. Just imagine a world where the vibrations from a jogger's footsteps could power their wearable fitness tracker. Or the rumble of a subway train could be used to light up the station. The possibilities are endless. Of course, it's important to note that this technology is still in its early stages. There are challenges to be addressed, such as improving the efficiency of energy conversion and finding practical ways to integrate these devices into our everyday lives. But the potential is there, and it's a promising step towards a more sustainable future. So the next time you're pounding the pavement, remember, your every step could be a small contribution to a big energy solution. Every step counts, not just for health but for energy too. What if your body heat could power your watch? Now, that's not a far-fetched idea. In fact, it's a reality we're inching closer to every day, thanks to a revolutionary technology that harnesses body heat to generate electricity. Let's take a look at a case study. A company called Matrix Industries has developed a smartwatch, the Power Watch, that runs entirely on body heat. You might be wondering, how does it work? Well, it's all about the science of thermoelectrics. In simple terms, thermoelectric devices work by exploiting the Seebeck effect, named after the German physicist Thomas Johann Seebeck. This effect is about creating a voltage when there's a temperature difference on either side of a material. So, in the case of Power Watch, the warm side is your skin, and the cool side is the ambient air. The watch contains a small thermoelectric generator that converts this temperature difference into electric power. The more heat your body produces, the more power the watch generates. This means that the watch could potentially have an endless battery life as long as it's worn. No more battery replacements or charging cables. This technology is not limited to watches. Imagine the potential applications. Medical devices like hearing aids or pacemakers could be powered by the body heat of the wearer, eliminating the need for battery replacements, which can be invasive and risky. It could also be used in wearable fitness trackers, GPS units, and other small electronic devices, making them more convenient and user-friendly. And while the technology is currently most effective for small devices, who knows what the future holds? As the technology evolves and improves, we might see it being used to power larger devices, perhaps even our smartphones and laptops. Harnessing body heat for energy is a promising development in the field of energy harvesting. It's a perfect example of how we can turn everyday phenomena into practical, sustainable solutions. The power to energize our devices could be within us, literally. Ever thought your Wi-Fi could power your devices? It's not as far-fetched as it sounds. Let's dive into a case study that brings this concept to life. Picture a technology known as radiofrequency energy harvesting. This innovative approach captures energy from the radio frequency signals that are around us all the time. It's those very signals that enable your Wi-Fi and mobile networks to function. Now, how does this technology work? Well, it's a fascinating process. It all starts with a device known as a rectenna, short for rectifying antenna. This device is designed to absorb radio frequency signals. Once these signals are absorbed, the rectenna converts them into direct current electricity. This electricity can then be used to power small electronic devices. And it's not just Wi-Fi signals we're talking about. This technology can harness energy from a wide range of frequencies, including those from mobile networks and even satellite communications. Imagine a world where your smartphone could be powered by the very signals it uses to connect you to the world. One might wonder, what's the potential of this technology? The possibilities are truly exciting. For starters, it could be a game changer for the Internet of Things devices, which are often limited by battery life. These devices could be powered continuously by the radio frequency signals around them. Furthermore, this technology could help reduce electronic waste by cutting down on the need for disposable batteries. However, it's important to note that this technology is still in its early stages. There are challenges to overcome, such as improving the efficiency of energy conversion and finding ways to store the harvested energy effectively. But the potential benefits, from reducing our reliance on traditional energy sources to enabling new kinds of devices and applications, are indeed promising. As we continue to innovate and explore, the energy around us takes on new forms and potentials. It's a thrilling time to be alive and witness the evolution of technology as we find new ways to power our lives. Our environment is full of untapped energy sources waiting to be harnessed. These technologies may sound like they are straight out of a sci-fi movie, but they are the future of sustainable energy. Imagine a world where the simple act of walking can power your smartwatch, where the heat from your coffee can charge your phone, or where radio signals can keep your IoT devices always on. This is the promise of energy harvesting technologies. They offer us a vision of a future where our energy needs are met in sustainable and environmentally friendly ways. Not only do they have the potential to reduce our reliance on fossil fuels, but they also present exciting opportunities for reducing electronic waste. These technologies can power our devices more efficiently and with less impact on our planet. By harnessing energy from unconventional sources, we can reduce our carbon footprint while also meeting the increasing energy demands of our digital lifestyles. The future of energy is not in more extraction, but in better harvesting, And that future is already here.